Now in this problem we are supposed to compare some things, basically inequalities and equalities and stuff like that. So let's see what the question is saying. P means greater than Q. Okay, signs are already given, you just have to okay, only thing which you have to do is that instead of not greater than, that is R means not greater than, you can have to substitute less than or equal to. If someone say not greater than, it basically means less than or equal to. Similarly, S means not less than, that is basically not less than means greater than or equal to. Okay, that's the only thing which you have to note. Everything else is directly given. So let's see. Statement number 1. Statement number 1 says that 2x S. What to do with S? S is greater than or equal to 3y. At the same time, 3x, that is T, equal to 4z. Okay, good. 9y and 8p are getting related with. Then they are saying that if this is the case, then 9y p, what is p? Greater than, is greater than, 9y is greater than 8z. So let's see which of the statement is correct. So let's see if this can be proved. Okay. So okay, we have 9y on the left side. We have to prove this 9y and 8z. Y is over here, z is over here, and x is the linking factor. Okay. So I'm first of all directly going to convert this thing. Here I have 9. So I'm trying to make this value 9. How to do that thing? I simply have to multiply 3 here and also multiply 3 here. I will get 6x is greater than or equal to 9y. That's what I got. Okay. Now on the right side I have 8z. Okay, it will be a little bit harder than I thought. Okay, no, it's not that hard. It's actually easy. Here we have 8z. So I want to link 8z is over here. To make this 4 as 8, I will multiply 2 here, I will multiply 2 here. I will get 6x is equal to 8z. Okay, good. Now I can actually link. I have 9y, I have 8z, 9y and 8z. Now, if you try to link this thing, 6x is greater than or equal to 9y, right? 9y. At the same time, we know that 6x is equal to 8z. So 6x is equal to 8z. So I can simply replace 6x with 8z. So what I actually got from these two statements, this one I got this one I got this. Basically from these two statements, I came to this. 8z is greater than or equal to 9y. And what is the statement saying? The statement saying is that 9y is greater than 8z. No. 9y is actually less. 8z is a greater. Worst case scenario, they will be equal. But anyway, this is not going to happen. So this is wrong. Now let's go for statement number 2. X q 2y. What is q? Q means less than. X is less than 2y. And yrz. What is r? R means this thing. Not greater than or less than or equal to. Less than or equal to z. This is z, okay. I'll just replace that with a lower letter z so that I don't confuse it with 2. And then they are saying if that is the case, then xrz or xrz. What is r? R is again this thing, less than or equal to. Okay, they are saying this thing. Let's see. We have x here, we have x here, we have z here, we have z here, and they are getting linked with the help of y. So first thing which we know is that there is a 2 coming in the between. So this part is actually telling us z is greater than or equal to y. That is fine. But here what is happening is that x is less than 2y. This is actually telling, this part is actually telling x is less than 2y. We have no idea how x and y are related. It might be less, it might be greater, because x is less than 2y can mean anything. It depends upon the value of y. If if you take the 2 to the other side, it will become x by 2 is less than y. So the only thing which I can say is that x by 2 is less than y, or see, if in this case I can say that in here I can put y is less than x by 2, or from this thing I can actually say that x by 2 is less than z. But here they are talking about x and z. See, I cannot come to a conclusion like that. There is a, I can only say is that x by 2 is less than z, or x is less than 2z. That I can say, but I cannot come to a conclusion like this. For example, let's see that if the value of y, so what did we do? Yeah, from this part, that is x is less than 2y. If the value of y is, let's say, 3, if the value of y is 3, then 2y is 6. That simply means that x is less than 6. If x is less than 6, if x is less than 6, then x can be any value. X can be any value less than 6, maybe 5.5 or 5, 4, 3, 2, 1, any value like this. But if you look at the y is still only 3. Okay, so y itself might be equal to x, less than x, or even greater than x. Sorry, x can be greater than 3, that is x can be greater than y, or equal to y, or less than y. So all the possibilities are here. And here from this statement what we found is that y is less than or equal to z. That basically means that if y is equal to 3, if y is equal to 3, z can be 3, or it can be 3.5, or it can be 4, 5, 6, any value greater than that. And we found that the value of x, it can be 5.5, 5, 4, 3, 2, 1, so it's like 5 x from this same thing, 5.5, 5, 4, 3, 2, 1, any value can be possible. So we cannot always say that x is less than 3. We cannot come to that conclusion, or less than or equal to. X can be greater than that also. Anyway, the thing is that statement 2 is also wrong. We cannot come to a conclusion. It's too unclear. Okay, so the answer should be D. That's it, guys.